So as written on the slide, there is a functional safety special interest group, a SIG, within RISC-V International, and I'm the chair. And maybe some of you, most of you know what functional safety is, but just a reminder, when you board an airplane, you enjoy functional safety to be implemented in the airplane. In your car too, when you press the brake pedal. In a nutshell, what is functional safety? It's the absence of unreasonable risk due to hazards caused by malfunctioning behavior. What will happen if your computer crashes, does not meet a deadline, and so on? And the goal is to protect people from injuries, from health damages, directly or through the environment. You can imagine an accidental pollution too that would endanger people. And the main point is the correct behavior of the safety features. And you can imagine the domains, the automotive domain. It's very important, especially with ADAS, automation, aerospace, medical, the energy, the railway, the defense sector, the industry, and surely many sectors we have forgotten to mention. Very often, functional safety relates to a certification standard, a body or a stamp or a certificate that guarantees that there is the absence, that functional safety has been correctly addressed. So there is one generic standard, IEC 61508. We heard about it very frequently. In the automotive domain, 26262 is very, very known. In the aerospace, there are also some standards. And you can see a small list of them. There are some people who mistake safety and security, especially when we speak in French, because we say sécurité for both of them. Almost no one in French says sûreté. They have common properties. Availability, system integrity is important for both perspectives. But the intent is very different. The functional safety is to protect the human from the machines. The security protects the systems and the machines from the humans, from the hackers. There are several properties for safety critical system. You can see them here. The availability, you want the system to be ready when you need it, or not to, to say that it's not ready to operate. Predictability, if you give the same inputs, you want the same results. Reliability, you want to resist the environment. The integrity, you want your data, your information to stay uncorrupted. Explainability, and that's important also for the certification. Why does the system behave properly? Observability is important too. We have to look into the system to know why it's correct. And simplicity is the ability for the system to be understood, and it will ease the certification, and it will surely avoid many troubles. The Functional Safety Special Interest Group. It's a forum to discuss functional safety in a RISC-V context. It's written on the label. The primary goal is to identify gaps and technical needs for functional safety, to advocate recommendations within RISC-V, and to identify specific problems that can be solved either by existing task group or SIG, or to spin off a task group. What's not in the specification, it's not a specification task group. We don't deliver specification. And in the participants, we have OEM, silicon manufacturers, software CAD vendors, IP providers, and many people from the research community. We are the vice chair from NVIDIA, Amit Pabalkar, and Thanks for him for the time he devoted to the group, and now Jaume Abeya from BSc is taking over this vice chair role. I think there is an election to be confirmed, but it should be this way. First, the first example of timing interference in a multi-core. Because of to address functional safety, you will want a task to be performed, very often performed in a given delay. If you press the brake pedal in your car, the reaction should be in maybe 50 milliseconds. You cannot wait for 1 or 2 seconds because your car radio will be uploading something in the meantime that would occupy the bus while you have while you press the brake. So in the figure you can see that we can have many contention between different initiators, and we want we would like to control them, to minimize them, or to assess them, but to keep them under control. So we can try to, for instance, to bound the worst case execution time thanks to different mechanisms such as cache partitioning, locking, or even cache deactivation. The performance, if you deactivate the cache, the performance will dramatically decrease, but the predictability will increase. You will know how much time will be used for this process. At the moment, we are working on spatial, the way it's written there, not spatial. And temporal isolation in multi-core SoC, looking at timers, scheduler, OSs, the interconnect, the memory protection. And we can also look at, for instance, the interrupts. When you have an interrupt, this includes non-determinism, and it can be an issue. We are also considering hardware safety mechanisms such as safe interconnects, and I saw the QoS SIG popping up in the slides this morning. Built-in self-test, everything about ECC parity, lockstep redundancy, clock monitors, voltage monitors, different watchdogs such as hardware watchdogs, and also monitors, many monitors to measure jitter, to measure delay, and to react accordingly. Our activity within a special interest group. Our past work was to build a wiki page, quite internal, although it's public, to capture the expectation from different perspectives, the software, the hardware, the OEM guys. Then we prepared what we call the blueprint. It's an internal document. It's public, but it's internal. The blueprint of the safety processor, where we have broken down our expectation according various attributes. And at the moment, we are preparing a white paper, something which will be shared with the community, which elaborates on the blueprint, but in a more comprehensive manner. There are several chapters in the document: partitioning, performance counters, error detection and correction, the QoS, priority management, redundancy, caches and tightly coupled memories, and support and tooling. And for each chapter, we will explain what are the needs, what are the desired features, which RISC-V existing features can be used to deploy these features, and also identifying gaps and recommendations. And at the moment, we have looked at the cache management operation specification that was recently published, and identified next steps that would be nice for functional safety. If you want to join the Functional Safety SIG, just do like for other task group, go to the list.risc-v.org, join RISC-V International, and I think all of you are already members, and then go to the SIG safety mailing list. And we meet every Wednesday, and we alternate between 2 time slots to accommodate people from America on one side and people from China on the other side. And every meeting is in the technical calendar. This is a list of the regular participants. So the criterion was that they attended more than 2 meetings out of 6 months. And you can see the list there. So there are significant players from industry and very well-known RISC-V contributors too. So this is it. Thank you. I don't know if there are questions, if we have time for questions. Yes, I think I have until 10. Okay. I didn't say there would be a Q&A session. You didn't prepare the questions.
Thank you. Mauro Olivieri from University of Rome. From your presentation, it seems that the focus is more on system-on-chip level design. Is there an interest also on safety-oriented cores?
On the cores?
On the cores, yes. Fault-tolerant cores, for example.
When we have identified the attributes and the features, we classified in 3 groups: the cores, the SoC, and the software. And what we can see is, from the safety viewpoint, very often it's at the SoC level. Most features are at the SoC level, but there are also some at the cores. For instance, performance counters are part of the cores. So you can have performance counters, of course, the one from the specification. And you can also have, for instance, performance counters on the buses. So both sides of the coin. And when you have performance counter, you will need some software to exploit them.
Thank you.
Any other questions?
Hello. Have you thought of any architectural changes that you may need to support? For example, some custom exceptions, some new exceptions in case you detect something, or is it all implementation related?
There are many things which are implementation related, but we have already identified a few points. And for instance, in the cache management, we have discussed maybe 1 year ago with Alan Baum, the CMO specification does not really address the needs we have, so we will need to discuss. But we first need to capture our needs and the gaps to be able to ask the CMO task group some new specification, or not changes, but how to address our needs.
Thank you.
I would have one question. Have you identified tools which could be involved in verification of safety constraints, which would be specific, open source tool, which would be specific to verification of safety constraints? Have you identified a number of tools, open source tools, which could be useful in an upcoming verification process? Verification, is there room for that? Is there a base code or?
No, that's a very good question, and it's even a very better question because I cannot answer it. There are tools. I know of a few proprietary tools for safety, for instance, working on worst case execution time and deadlines and the scheduling stuff. I'm not aware of a tool. By the way, we are not focused so much on the tooling or the solution. We more look at the RISC-V specification and how they fit our needs. And we try even, so I mentioned many implementation details. So sometimes what we say is that people, when safety people design something, they will enjoy these features from an architectural viewpoint. But of course, it's RISC-V International. We don't specify any architectural specification. So we have to come to the ISA or to the ISA or maybe the platform level specification.
Other question?
For one question, one more. Otherwise, we can give back these 3 minutes to the next presenter.
Absolutely.
Thank you.